Hello everybody! Today in this lesson you guys will be learning how to recognize polynomials and also how to name them. Because polynomials are variable expressions that only involve addition, subtraction and multiplication, there can be no variables dividing. So this is very useful for us to recognize polynomials. For instance, take a look at the very first example here. This one, number 1. Okay? This is a polynomial because it involves multiplication between the coefficient and the variables, right? Multiplication and addition. This one does not have subtraction. It does not have to have all of them. So that's the reason why this one is a polynomial. On the other hand, notice the one on the right. There can be no variables dividing, and all of these variables are dividing. That is the reason why then this first example here on the right side is not a polynomial. This second example on the left side is a polynomial. The coefficient is -9, is just negative, but it's okay, and the variable is raised to the third power. It only has one term, but it's perfect. It's a polynomial. On the other hand, on the right side, what's our problem with this one here? If you notice, the exponent, it's negative. And the exponents can never be negative. They must always be whole numbers, such as, 0, 1, 2, 3, and so on. So this is the reason why this expression then is not a polynomial. Now let's analyze this third example here. 1/2 x plus 8 is clearly a polynomial. The coefficient is okay, that if it's a fraction, it could be a rational number or an irrational number, any real number actually. But the one on the right side, notice again the problem. The exponent is not a whole number. It's a rational number. So one more time, this is clearly not a polynomial. Now the fourth example on the left side, no problem. The coefficient, again, like I said before, it can be any real number, square root, fractions, whatever. That is not a problem. It only has one term. It's okay. So these two are polynomials. Now, on the right side, notice that the variable, it's inside the radical. These two expressions are identical. Squaring a variable or squaring a number is exactly the same as raising that value to a fraction that is 1/2. So that is the reason why, again, these two are not polynomials. Okay, so now we're going to practice naming polynomials according to their degree and also according to their number of terms they have. Okay, let's first focus on the degree. The degree is nothing more than the highest power of the variable. The highest power of the variable. So in the first example, we can clearly see we have only 7, right? This first example here is 7. So in algebra, we can consider constant or lonely numbers that are actually lonely simply or look lonely because they multiply a variable whose exponent would be 0, because this is the same thing as 7 times 1, which is of course simply 7. So that's the reason why the degree is 0. So the name is simply a constant. We knew that, right? And because it has only one term, then we're going to call this one a monomial. Okay, let's take a look at the second example, 7x plus 5. Okay, what would be the degree? Okay, it's 1. How come? Because the first power, the variable has an invisible one right there. Therefore, the name we're going to use for this one will be linear. So this one is a linear polynomial. It has two terms. And because it has two terms, we'll call it binomial. Like bicycle, it has two wheels, so bi, right? That's a prefix. Mono means 1, bi means 2. The third example, notice it has 3 terms, right? So we can go ahead and write that down right away. 3 terms. And the highest power of the variable is clearly 2. That is the reason why this is the degree 2. How do we call these ones? We call them quadratic. So this one is a quadratic polynomial. and because it has 3 terms, then is a quadratic trinomial. Now, let's analyze the next example. It's a 3rd degree polynomial. Take a look. Again, the highest power has 3 as the exponent. That's why it is 3. So the name using such degree is cubic. And because this one also has 1 term, this example, negative 5x to the 3rd power, then is simply a cubic monomial. Now take a look at this next example below. It has definitely more than 3 terms, right? More than 3. And the highest power of the variable is 4. This polynomial is, by the way, written in standard form, from biggest to smallest power. Let's take a look. So how do we call these ones? So the name we give to those polynomials whose degree is 4, it's quartic. And because this one has more than 3 terms, then it's called a polynomial. Poly is the prefix that means many, right? The last example, if you notice, it has 2 terms, and the highest power is 5. That's why the degree is 5. So the name we will give this one is a quintic binomial. So you can name these ones this way. The first one, 7, you can say it's a constant, it's a monomial. The second one, is 7x plus 5, you can say a linear binomial or a binomial of degree 1. The third one is a quadratic trinomial or a trinomial of degree 2. This next example, negative 5x cubed, you can say a cubic monomial or a monomial of degree 3. Then the next one, a quartic polynomial, this one that is long, or a polynomial of degree 4. And finally, the last example, you can name it a quintic binomial or a binomial of degree 5. So as you can see, this is not hard whatsoever. Just watch it again so you can remember it forever. Enjoy it!